Welcome, my one student, and those of you viewing from home, to day 10 of Foundations of Programming. Today, we're going to start lesson 8, which is going to be classes and objects. Classes and objects is really object-oriented programming is the reason why this course was created. One of the hardest gates in our programs that you're going to encounter is going to be the very first assessment that's going to be administered, which is going to be object-oriented programming. Now, this assessment is typically given to you guys about 2 weeks into the course. Granted, don't forget that the first 3 days are kind of like a loss, because you're learning, about each other. It's like orientation, right? You're learning about the staff, program, uh, what's to come. You're doing icebreakers, you're doing stall fest. Uh, it's a bunch of admin stuff, right? Just kind of getting you ready for the course. Your Linux commands. So the stuff that we started with on the first week of class, that's kind of what you're hitting on. Um, so the first 3 days are really like a loss. So realistically speaking, you won't start seeing code until maybe the fourth day, the fifth day. The next week comes along, you will have a full week of our object-oriented programming lecture. And then that Saturday, it's like, all right, here's your assessment. Good luck. Right. What's going to happen is that Saturday, you might get a slight review on object-oriented programming for about 2 hours, if any. And then noon will hit and the assessment will open. And the assessment will be due Monday morning before 08. Now, if you're like me, you will start it and you will somehow mess it all up and have to restart it Sunday afternoon. Uh, so you do not want to be in that situation. Now, it's not to say that if you don't go through it in object, in foundation program, you won't be successful. We just do it this way, so you have you've seen it before. It's not completely new, and it's easier for you to soak it in the second time you see it. But without further ado, let's go ahead and jump into classes and objects. And the first thing we're talking about is what is a class. My favorite part about class and objects is it's kind of like seeing it come to life. Classes really is what I like to call a blueprint, right? Think of it as a factory for creating a new object. Um, it's really a blueprint. And the way I like to see it here is kind of like this car that you see in this image. If you were to create the blueprint for a car, there's certain things that you would take into consideration, right? First and foremost, what are the basic components of a car? Well, first and foremost, it requires probably some kind of a body, right? It's going to require wheels. It'll have some kind of model. It'll have a color. It might have to have a fuel type, engines, steering wheel, right? You need some way to steer the vehicle. It's going to require doors. Some cars have more doors than others, right? Um, all these are basic requirements of a car, right? This is everything that would go into a blueprint. Now, you define the blueprint, and this analogy, that's our class. You're defining what's going to make up this class and its abilities and what its characteristics are going to be. Class objects can be used over and over again, so it's also a way of keeping your code dry, which is one of the concepts that we like to live by. Dry, don't repeat yourself. Um, if we are able to automate something, whether just put in a function so we can just use the function instead of writing the code over and over again, we would do that. And that goes with cars, right? I'm sorry, not cars, classes. It allows us to consolidate our code in something that's reusable, so it keeps us from repeating ourselves. Right? Think of like a video game. Um, a video game where you have like a wave of monsters. Well, it would really suck to have to code out every new monster that we instantiate into our game. It wouldn't make sense to have to manually write the code for every single time a monster is spawned. Well, if we can consolidate it into some kind of function, or in this class, or in this situation, a class, we can use that class or really a blueprint to recreate this monster, alien, this creature instantaneously over and over again without having to write the code manually. We just call the class. Here, see how they use or leverage the car class, and they're able to create different objects out of this class, right? So the class is the blueprint, and then the actual creation, of that item that comes from the blueprint is the object, right? Once again, the blueprint is the class, and the actual, physical creation of it is the object itself. And having these characteristics in our blueprint here, the class, like color, make, model, and fuel type, we're able to use that information to create unique versions of it. Notice how this car object is a yellow Ford Mustang that runs on gasoline. The car object here is a red Toyota Prius that's a hybrid, and the other car is a blue Volkswagen Golf, which runs on diesel. So, all three of these objects are a variation of the car class, but they have their unique properties, like you see here. Do I have any questions, Thomas?
Nope.
Awesome. Now, class syntax. How do we begin to write a class? So, like everything else, when you wanted to create a function, you would call def, stuff like that. Here, when we're going to create a class, there's a specific keyword. That's going to be the keyword class. So class keyword is used to define a class. And then the naming convention of a class by default typically is we start it with a capital letter, right? So when we define our variables, we never really cared about the capitalization of that first letter. We just did snake case for everything. In a class, we start with a capital letter for the naming conventions. So here you see class pet, right? And then you're going to open up the class creation with a colon. This does not require the open brackets like you would a function. The open brackets are going to go within here. So once again, you start with class pet. Now, after initiating the creation of a class, the part that comes next is going to be the functions that belong to this class. Now, by default, functions, right, when they're standalone, they're called functions. When they're used inside of the creation of a class, we start calling them methods, right? Which is why, Thomas, you've known me for a while now. Sometimes I reference like methods or classes, and I almost use those words interchangeably. Methods are technically functions. It's just that the methods belong to a class, right? So now that we're going to start using these functions inside of the class, these are going to be referenced as methods, right? So functions that are part of a class are known as methods. And one of the very first things that you're going to require in a class by default is typically going to be your init method, right? Init is short for initialize. The init method is automatically called by Python when creating an object of a class, and you'll see what I mean by that. But what happens is we require an init method, and this init method is what Python is going to read when creating your class. To create this init method, you have to use the keyword of def, right, to start the function, or in this case, a method. And you're going to have to create the method, the init method, by using the double underscores to the left and to the right. This is what we call dunder methods. These are methods that change kind of like the settings of the class, if that makes sense. These are usually identified by the double underscores to the left and to the right. Hence the name dunder methods. So it's double underscores init followed by double underscores. It has to be the keyword init, right? This is what Python is going to be looking for when you try to create an object. And it's going to specifically look for the init method so it knows how to create this class or object, right? It's kind of like Python trying to read the blueprint. It's going to look for like the steps, right? Or the ingredients needed, right? When you go to create a cake, right? You read the recipe. What do you look for? You look for the directions, for the instructions, for the ingredients, that's all going to be found within what we call here the init method, right? So Python's going to look for the init method, and within the init method is where we're going to define all the properties that are going to belong to this class. Now, when writing methods in a class, the first parameter that you're going to pass in is going to be this parameter you see here called self, right? This is something that the class requires by default. It can be a little weird to understand at first. Uh, this is just, it's kind of like saying like this. Hey, Thomas, you're familiar with the keyword this, right?
Yeah.
Right. It's kind of like using that, right? It's saying that this class is going to have species and name. Self. It's almost like talking about itself in third person if you think about it. Uh, but it's going to require the self keyword. So just be aware that if you try to create it without the self keyword, you're going to get an error. So be well aware. So the very first parameter you're going to have to require to be put in here is going to be self. And then after that, you're going to put whatever properties or really what we call attributes that are going to belong to the pet. So notice here that we pass in species and name. Afterwards, we have the actual attributes or properties that are going to belong to this class. So we prefix these with the keyword self. This way, when Python reads this, it knows that we're referencing to the class that this is written inside of, right? It's like, once again, using the keyword this, right? This has a attribute called species, and we're going to assign it the parameter called species from the parentheses, right? Next line here is saying that, hey, this class has a attribute called name, and we're going to assign it the value from the attribute, or sorry, from the parameter called name, right? So whatever we pass in here as arguments when we call the class, that's what's being assigned to these attributes, right? These properties. Now you might notice something, and that's this very fact that there is an underscore between the self dots and species. Now, why do we have an underscore? You want to take a guess, Thomas?
I have no clue. Abstraction?
It's supposed to be more like what was the term I'm looking for? Encapsulation, maybe? Hmm. So, have you ever used something like Java? Have you ever tried
Mm,
coding in Java?
No.
Okay. So there are programming languages that allow you to make things private. So what does that mean? Is if you create an object of a pet, right? Let's say the pet object is going to be a dog, and his name is Fido. When you make an attribute private, which other languages allow you to do that, you could say like, hey, this will be a private property, and we're going to assign it dog. This will be a private property, and we're going to give it the name of Fido. That means that other people can't change it, right? They can't change it. They can't access it uh, directly. Well, Python doesn't have the ability to make things private. So what we did is we started putting double underscores or underscores behind the name to kind of make it like private. And I'll show you how that works in a bit when we get to some code. Once again, the init method itself. So the init method does not need to take parameters for every data member. It depends whether it will always be initialized with the same value. And by that, I mean like this. Check out this code snippet here. We have two classes, right? They're almost the same thing. One is called non-customizable robot. That's the one on top. And the one below is called customizable robot. The only difference between these classes is how they're taking in the data. Let's look at the top one, for example. The top one, inside the init method, we only have one argument, and that is the mandatory one, which is self. That is it. It requires self, so it knows how to run this method. We pass in no other argument in here or parameter. Below it, it has four different properties. We have sensors, actuators, name, and state. And we hard code the definition for these by passing in directly the data that's going to belong here. So here we're saying that sensors has a list of gyrometer as a LiDAR and a camera. By default, if we were to create a non-customizable robot class, it'll start off with these values. It will start off with a list of actuators being wheels and LEDs. It'll start off with a property called name, and then the value will be data, and the state will be set to on. So what this means is I do not have the option to pass in any arguments when I create this class, because I didn't set it as an option to take in parameters because there's nothing here. But by default, it'll already start off with some because I hard coded it in here, right? Hence the name non-customizable robot. I'm not able to pass in arguments when I create it. It'll already start with default values. Does that make sense, Thomas?
Yep.
Right? It'll make a little bit more sense when we see the one below it, where you see here it has three parameters passed in. Customizable robot has the ability to take in sensors, actuators, and name as arguments. And instead of hard coding a preset definition for sensors and actuators as well as name, we're going to pass in whatever is being given as a parameter when creating this class. So this will allow us to customize this robot when creating it, right? The only thing we can't customize is the states. As you see here, it's set to off by default. And same thing with the operating system set up to Linux. But this one at least lets us customize three different other properties where the non-customizable robot didn't give us the ability to do any of that. By default, it just started off with these. And once again, self refers to the object itself, as in saying like I. I have sensors and actuators and name and states, right? I. Once again, it's like talking to itself in third person. All right. So let's do a little demonstration here. You can follow along. Inside of lesson 8, I want you to create a new file. And we can just call this classes and objects.py. All right. Okay. Now, let's go ahead and create our very first class, which is going to be class. Let me zoom in a little bit. Let's get rid of this here. Our class will be pet, right? Just like I mentioned to you, it has to have the capital P at the start and then followed by the colon. The very first method that we're going to pass in will be our dunder method of init. So our init method. And if I don't pass in the self, I'm going to get an error.
Are you typing something or are you still presenting?
I am typing. Can you not see
Oh,
it?
no, I just see your presentation.
Okay. How about now?
Oh, now I do.
Okay. I think I was sharing the wrong screen. My apologies. So here is my init method. We're going to require the self keyword in here. And I'm going to pass in, as we saw earlier, species, and let's pass it name, or I'll do it name species. Name species. I'm going to say name. And notice I'm not going to put the underscores right now. Let's keep it about the underscores, and I'll show you the difference in a little bit. So we're going to say self.name is equal to name. And we'll say self.species is equal to species. We're quite literally just assigning whatever's going to be passed in as arguments to the properties that we're going to be creating. We're almost creating, it's like pretty much creating a variable, right? You're creating a variable and you're passing the arguments as a value to these variables. Make sense?
Yeah.
And we'll keep it simple for now for our very first example. But we're going to go ahead and create our very first object. So this here is the definition of our class. This is our class. When you're ready to create an object, you want to unindent and come back to the global scope of your code, and you could then continue on like normal. So we'll create an object. We'll call it pet1. Pet1 is going to equal to an object. So how do we create an object? Well, we have to call the class. So we're going to say pet. I'm going to open and close parentheses. And notice right here, right off the bat, you can already see it's already popping up like a hint. It's saying that I need two arguments, name and species. It's even showing to me that name is, it could be any and species can be any. I think I could do something like this. Let's see. Name is going to be string. There we go. So I can add, have I shown you this before? What I just did?
A while back.
Okay. Yeah, you could do this for classes as well. To kind of give a hint of how it's supposed to work. So now when I'm trying to create a pet, notice that it says name is supposed to be a string and species is supposed to be a string. Gives me a hint of what I should be passing in to my class when trying to create it. So I'm gonna call my pet Oliver. He's the name of, I actually do have a pet named Oliver, and he's going to be a dog. So I'm passing my two arguments. And now let's see how this works. Let's go ahead and print out pet1. Now, this might not be exactly what you think it's supposed to give you, but you'll see what I mean. Let me go into lesson 8. So when you print, oh, I need to save this. Where did I save this lesson? Oh, I saved it in the wrong area. There we go. When you print an object, you're gonna get something funny back. Right? So I ran my code. When I ran my Python file, it should have created my pet object, and then the only thing I have being printed out is here, where I'm printing out pet1. Notice that I get something back that's very weird. It's a little unreadable. I see here that says main. I have a pet object at 0x7f6fe, and then a whole random set of numbers. It's like a hash. It's a hash number, right? So here I am printing out my object. So this is a default way of how objects are shown to you when you try to print them out. It tells you that it's an object. It tells you what type of object it belongs to, and it tells you where in memory this object is stored, right? Now, this doesn't mean much to us, right? It's a little unreadable, really. Um, Now there is a way that we can change that. Let me show you real quickly. Oh, I don't have my backdrop. Never mind. Um, I forgot what it was. I think it was like dot name or underscore name. Let's see. Python Thunder methods. I believe it's underscore name or maybe string. I used to use string, but someone showed me a different way of doing it. Uh,
Wasn't it right there on your slide?
no,
Oh,
I never had it in my slide. Um, I think it's this one here. I think you should be able to use the REPR Dunder method or the string Dunder method. We'll use the string one, but either one of those works. So right now, this is the default way that Python will print out your objects, right? This is how it just does it. You are able to override this, and I'll show you real quickly. Typically, I show this to you later in the class, but just you and I, so I don't care. So let's go ahead and do that. We can say define. We're gonna say string, and we're gonna pass in self, right? And all we're gonna do here is say we're gonna return. We're gonna return something, right? What we're gonna return is some form of a formatted string, right? Now, this could be whatever your heart desires, Thomas. For this situation, I'm going to do something like name, and then I'm passing self.name, and I'm going to say species, and I'm going to pass in self.species, right? And now when I run this file again, instead of printing out that little encoded message of the object type and location, notice here that now when it prints out here on line 12, the pet, instead of giving me that hash number, I'm getting the string that I passed in for my string dunder method. So here I see name is Oliver, species is dog, right? So now when I print out objects, I can see a representation of what it should be. Make sense?
Is that because it runs top to bottom, so it automatically will do the bottom method?
When I think it runs it when I run the print message. This one will run by default no matter what, every single
Mm.
time because it's creating the object. But I think this will only run when you use the print message.
Or is it because we're returning something?
But we are returning something, yes. Any other questions?
Mm. No, I was just trying to figure out like what triggers this to actually just do it like that.
So the print statement, I don't know how it works exactly how under the hood, but
Mm.
when Python sees its print statement, it's going to check the object. If there's a dunder method, it'll run the dunder method. And if not, it'll just by default give you the original print statement. But if it has a double underscore string underscore method, it's going to run this. And the only thing this function is doing is returning something. So it's going to return this bad boy.
Gotcha. Because I mean, the same would be if you just instead of doing the uh, dunder we just made, wouldn't it be the same if we did print and then like pet under one dot name?
Yes. And I'll tell you why you don't want to do that in a little second.
Oh, okay.
Right. So here we have a way to change that, but that's a good question, right? Why don't we just say something like pet1.name, right? And then just run that instead, and I get here Oliver. That gives me the same result. Well, the reason why I don't want to do that, Thomas, is because of in we have polymorphism, abstraction, encapsulation. I'm really bad at these. Encapsulation, right? We don't want for people to have access to just anything on our class. There has to be rules to this, right? Um, one of these is the very fact that they should not have direct access to our properties. That's a no-go. What if this was a class for something like a bank account, right? We have something like account ID, like self.account ID, self.routing number, self.account balance. Should the user be able to say like, Thomas account dot account balance and change your -$3 because you overdrafted to 2 million? Probably not, right? So should someone
No.
have direct access to these properties in a class? No, right? So we want to encapsulate uh, these properties that we have in our objects to ensure that not anyone can get access to them. So that brings me to the reason why we have underscores. So when you put double underscores before a variable, notice that it doesn't allow you to necessarily access directly. And even if you try to do pet underscore one dot underscore underscore name, it doesn't allow you to use it directly. Right. So what this does is it makes this property here private. That way people don't directly have access to these variables, which is why on the slide you saw it like this: underscore name, underscore species. So you want to put double underscores, right? Double underscores will make it private. I think one underscore doesn't. I think they can still access it if you use one underscore. Yeah, there you go. Yeah, the slide's a little outdated. You want to put two underscores, all right, on your attributes here. That way they can't access it. But once again, going back to what I was telling you, normally everything should be privatized. There, unless someone needs to have direct access to a property of a class, there should be no reason why that class is not private. Why you don't have double underscores before the property attribute. Does that make sense?
Yeah.
I did it without it earlier so we can have this conversation, but this is your standard way of writing it. You want to put the double underscores to ensure people don't do exactly what you said. Why don't I just do pet underscore one dot name? You do not want to access properties directly. So then that begs the question. Well, Roger, what if you want to be able to use something like do something with those attributes? Shouldn't they be able to like view it? Maybe you don't want them to change it, but maybe like people should be able to view their account balance. How can somebody view their account balance if it's private? Well, let's say like right now, species is private, so I can't do something like pet one species because it's gonna give me an error. It says it has no attribute species. So how do we get that right? Well, we use what we call a get method, which is going to come, it was supposed to come later in the class, but I can answer it now. Or we can say something like uh, get get species, where we just do something as simple as return self dot underscore species. And now they have access to this attribute, but they can't change it directly, right? So they shouldn't have the ability to call this directly themselves, but you should be able to create a way for them to be able to view what it actually is. This keeps the property safe, but it still gives them access to view it without manipulating anything. Does this make sense, Thomas?
Can you scroll down real quick to your print statement? Okay, so you have to do dot and then the method.
Yes.
Okay. Because I just tried dot species and yeah, no. Okay.
Yeah. So yeah, I call this get species, right? This is
Okay.
what we
Yeah.
call a getter function or a get method, really.
Yeah.
We're
Getters and
able to,
setters.
yeah, getters and setters, if you heard that term before. Yeah. This is a get method, which allows to get properties without changing them. That way it keeps them from directly accessing these data attributes, but still being able to view what they are. I'm sure you've seen us use functions in this manner, right? This is why sometimes I reference them as methods, because technically, if they're being used like this, they do belong to a class. All right, so the functions that you've been doing or using, like dot title, it belongs to a class. It's a built-in Python class method, right? Make sense?
Yep.
The print statement, that's a function, right? Because the way it's being called. Notice how you call print and then you pass in the argument it takes. Unlike something like a class method, you call the class or the object itself and then the method that it's going to belong to.
Like console.log.
Right. So let's go ahead and continue forward. So what are these objects? The class objects are made are just containers for storing data and functionality. These objects have properties like name or species, like you saw earlier, but they can also have methods that do things. Right. So remember, it's really ultimately this is a tool for organizing your code. So let's talk about that. The ability to do things, methods to do things. So think of a dog. What can a dog do? Or what should a pet do in general? Well,
Trick.
we can do something simple like speak, right? And speak should have something like, let's say, sound, because every pet should have a different sound. And they should just do something as simple as return sound. Or we could say for I in range of 3, print sound, right? And we can say pet1 dot speak. What am I doing? Oh, my apologies. I messed up here. This should be bark. Python. Where am I? There you go. Bark, bark, bark. Right? Pet1 is a dog, which is why I give him the sound of bark. And when I run the command to speak with the bark sound, he should be able to tell it to me back 3 times. We can make this a little bit easier. We can just go ahead and give him its default sound when we create him. Sound, and we'll set string self dot sound is equal to sound. So now we don't have to we don't have to keep passing the parameter every time we try to make him speak. Print self dot sound. I already changed that. What's going on?
You didn't pass it in for
Oh,
pet one.
thank you. It was driving me crazy. I was like, what happened? Bark. But there we go. So that's one pet. We should be able to do something like pet2 is equal to pet. We'll call this one Mr. Mittens. It's gonna be a cat, and he should be able to meow. Pet2 dot speak. We'll do pet3, which will be he'll be I don't know what to call him. Ozzy. He will be a parrot, and he'll say something like Polly want a cracker. And now I create three different objects, right? They all have the ability to speak to me. One says bark, one says meow, and the parrot just annoys me, right? But I was able to use this blueprint of a pet, reuse it, and create different versions of a pet. One is a dog, one's a cat, and one is a parrot, right? They all have their individual species and name, as well as the ability to give me their speech to me when I tell them to talk, right? Any questions, Thomas?
Nope.
All right, let's go ahead and move forward. So we talked about private data members. Some languages have a keyword called private. That means certain data members or methods can be accessed from outside the class. Python does not have such a keyword. So the convention is to start that data member of method with an underscore. Right? This is a convention that we came up with as Python developers to be able to mimic the same functionality, even though it's not built into it, right? Notice in our bank account class that we have specific methods that set the values of certain data members. All right, so we have account ID set to account ID, balance set to balance. We also have methods that can get the value of certain data members as well, which is the get account ID is going to return the self dot underscore account ID. But something here that you see now is the set account ID, right? So just like you mentioned earlier, the term of getters and setters, they shouldn't be able to access the data members directly. But let's say, hypothetically speaking, you end up having to share the ability to change one of them, something like an account ID or username. We should be able to create a setter method that can allow them to change only that, right? And that's what they did here with the account ID. This is prefixed with the keyword of set. So we're going to set the account ID, and they should be able to pass in a new ID here. And notice it's as simple as calling the data attribute and then reassign it to whatever was passed in as an argument. So here's your getter and your setter. Cool.
Yep.
Once again, this idea is important because it gives them more control over who can access the data members. We already talked about this. Printing object of a user-defined class. So printing this kind of object returns the class it belongs to, and it addresses in memory. Not very helpful, right? So this, as I mentioned to you, what class it belongs to, and then where memory it's at. Once again, it doesn't say anything to us. I have here that later in the course we'll talk about it, but I already did, so it's okay. We can move forward. Objects everywhere. Yes, everything that you've been using, even though you haven't noticed it, you've pretty much been using object methods for a long time. Method like dot title, dot split, right? These are built-in methods that belong to a class in Python. All right, your first exercise, the taxi cab. All right. So in lesson 8, you have the taxi cab assignment. It's actually fairly simple, I like to believe. Let's go ahead and split it up. Write a class named taxicab that has three private data members, one that holds the current x coordinate and one that holds the current y coordinate, and one that holds the current odometer reading. An odometer simply measures the distance a car or bicycle traveled by keeping track of how many times its wheels have turned. So if you travel 1 unit left and then 1 unit right, you'll be back where you started, but your odometer will tell you that you've traveled 2 units. All three data members should be updated as needed so they're always current, right? The class should have an init method that takes two parameters and uses them to initialize the coordinate and also initializes the odometer to 0. Notice that the odometer isn't customizable at creation. It is by default set to 0 because a brand new car should have no miles on it. The class should have get methods for each data member, like get x coord or get y coord and get odometer. The class does not need any set methods. It should have a method called moveX that takes a parameter that tells how far the taxi cab should shift left or right. And it should have a method called moveY that takes a parameter that tells how far the taxi cab should shift up or down. All right, here you have a little code example. Let me train these up again. Right, notice here they start off the cab, they pass in the x and y coordinate. Right, so this creates a taxi cab object at coordinates 5 and -8. They call the cab method called moveX and pass in 3, so it moves the cab 3 units to the right. So they should be able to update the x coordinate. The next one updates the y coordinate to -4 units. So x is your horizontal plane, so x should be left and right, and y is your vertical plane, so it should be up and down, right? Afterwards, you should be able to use the method of get odometer to allow you to view what the current reading is. When you first create a tax cap, it should be at 0, so you should see the overall change after giving your move commands. Right? The odometer reading should match whatever you did. So, for example, 3 plus 4 plus 1, even though these are negative units, each unit represents how many times it moved. It'll tell you what the updated odometer should be, and you should have an updated location of your tax cap. Do you have any questions, Thomas?
So the get odometer should return not only the amount of units moved, but also its coordinates.
No. Um, the coordinates are being given by this a class that has a get method for each data member of get x coord, get y coord, and get odometer. So those have their own individual get methods, as well as move x and move y. Make sense? I mean, you can create a function if you want to see that too. You can add it if you want.
Yeah, no, I was just trying to determine what the cab.get odometer should return because it looks like it's asking for units and the coordinates where it ended up at. Or is it just asking for it to return the units?
Just return the amount of units is moved.
Gotcha. Okay.
To I know it's a little misleading when you see this, but no, you should not have it like this. You can maybe if you want create an additional method called get hold position or get position that can return x and y together if you would like that.
Gotcha. Okay.
But yeah. All right, give it a try. Time is 6:33, so do take a 10-minute break. After you come back, let's give it 10 minutes. So let's reconvene at 6:53. I'll see you
Alrighty.
in a bit. All right. Let's go ahead and do this assignment. I'm going to split my screen here so I can see the readme on the right side. Let's close this up and let's create our taxi cab class. I'm going to say class taxi cab. We're going to define our init method so our Python can know how to create our objects. And if you see here, it's going to have 3 data members. So don't don't let this mislead you, right? Just because it has three data members does not mean it's taking three arguments, right? Because as we know, we can either add the ability to customize by passing arguments, or we can code out the setting or the values to these data members ourselves, right? Uh, but it should have only two arguments that it's going to take in. So we should have something like X chord and Y chord. So one that holds the current X, one that holds the current Y, and one that holds the current odometer reading. And we get a little bit more detail exactly how the init method should be done later on here. We see the class should have an init method that takes two parameters, right? Even though it has three data members, it's only gonna take two parameters. It's gonna utilize them to initialize the coordinates and also initialize the odometer to 0. So we'll say self dot x chord is equal to x chord. Chord has two O's. Is that correct? I think it's correct.
Yeah.
Yeah, yeah. English is hard. Self dot y chord is equal to y chord. And finally, we say self dot odometer is equal to, set it to 0, right? Because a brand new tax cap shouldn't have any odometer reading. Awesome. Finally, we can go move on to the next methods here, which is going to be our get method. So we'll say get x chord. My laptop about to die. I'm going to connect it real quick. All right. Get x chord and each self, and this is simply going to return self dot x chord. We'll do get y chord. I'm forgetting the extra O's on all these. Self return self dot y chord. And we need a getter for our odometer. Get odometer. Return self dot odometer. Awesome. It should have a method called moveX that takes a parameter that tells how far the taxicab should shift left or right. It should have a method called moveY that takes a parameter that tells how far the taxicab should shift up or down. So we'll do X first. We'll say define move X. And this needs to update our coordinate for X. So we're going to say self dot X chord is going to plus equals, and we need to pass in a new value here. So we'll say new X, and we're going to take a new X, right? Once again, it should have a method called moveX that takes a parameter, which is new X, as a parameter that tells how far the taxi cab should shift left or right. Now, the issue here is that what happens if we get a negative number? Hmm, I think it won't make a difference here, right?
For me, it was telling me that it was, that's where I was telling you my passing in was getting messed up because it was saying takes one positional argument, but two were given.
We'll check it out in a bit. No biggie here. We'll say define move Y, self new Y, self dot Y chord is equal to or plus equals new Y. And then finally, we should be able to, oh, I forgot. Every time we move X coordinate, we need to update our odometer as well. So we need to say odometer plus equals whatever our x moves, but it has to be absolute because we don't care if it's negative or positive. We need to be able to just get how many times it moves. I'm going to do the same thing for a y here. We'll say self.odometer plus equals the absolute version of new y. So our odometer can reflect every time it moves. Now let's check it out here. We'll say taxi 1 is equal to taxi cab. We'll start off at 0 and 0. We'll say taxi cab dot move x. We're going to move 5. And we're going to move our y coordinate to -2 and see how that works. Finally, I want to see what my odometer is. And we can run the taxicab.py. And of course, I'm not printing any of these out. How silly of me. Once again, run it. And I moved, but I never checked it. So this should be. I'm done. Let me remove the print statements here. Remove the print statements here. I'm going to say taxi cab or print taxi 1 dot get x cord and taxi 1 dot get y cord. And now I should get something different. There we go. Uh, it looks like my coordinates stayed the same. Notice that it's still 5 and -2. X, oh, that's good, right? Because we started at 0. That's perfect. We started at 0. So when I added X, move X by 5, it changed it to 5. I moved Y by -2, so it changed it to -2. So it quite literally reflected that. Let's go ahead and run these commands again. But this time we're going to change this to a 15. This one will change to a 7. Actually, let's make this -15. And then let's copy this print statement one more time and see how it looks. So this was 5 at first. We add -15 to it, so it should be -10. So that worked perfectly. Our y ends up being -2 after the first time we run it. We add a +7, so it should be a +5. And notice that the 29, so it's taking count of how many times we moved it. If we were to add 5 and 15, that makes 20 units with the x coordinate. Add 7, that's 27. Add 2, that's 29. So our get x core, or really move x and move y, are working exactly how we wanted to. And then same thing with the odometer. We're able to add the absolute version of the values whenever we move. Once again, for for those of you that forgot how the absolute method works, it's going to take a number even if it's negative and it'll make it into a positive. So it's going to return to you the absolute version, the absolute positive version of a number. Do you have any questions, Thomas?
The hmm, yeah, mine's not returning anything like yours.
Sure. Go ahead and share your screen. I don't know why my face looks black and white. That's funny. My lighting in my room sucks.
Can you see
Okay,
my screen?
I can.
Okay.
Mm.
And that's what it's giving me.
What's that initial five that you have there? Says
5.
five
Yeah,
bound met in the print statement.
that's the only thing I can assume is right there. But
Move X by five, but move X doesn't print anything. Run it again.
maybe I need to move into the folder again that kicked me out of it.
CD.
Okay, that should be good. But yeah, no, same thing.
Type in ls. Print the typecap.py instead. No, I was saying like on my bad. Run the typecap instead. So Python typecap.py. That's how we should be running it. But still X get X chord. By the way, get Y chord is a function or a method, so it needs parentheses on line 29. Get
Mm,
Y chord. Try it again.
okay,
Stop
there
run,
we go.
stop running it with the play button. Use the terminal. You gotta get used to that. But okay, that's working at least.
Okay, there we go.
So five, -2, and then get odometer. Yeah, so it's working. It was just that you were calling the method incorrectly because they're missing parentheses.
Right, it was just returning the object
Hmm.
data like the other one. Okay, that makes sense now. All right.
Yeah, no problem. All right. Let's go ahead and continue. We're pretty much almost done with this first lesson. The rest of it should be okay. We'll do one more before we call it today, which is going to be the standard deviation. I'm not gonna lie to you, I hate this one because I always have to look it up. But let's go ahead and check out the standard deviation. I'm sharing my screen, correct? I believe I am. All right, the next time is going to be the STD dev standard deviation. So go ahead and open that bad boy up, specifically the README, right? I'm not going to read the README because it's fairly long, but what you're going to really need is going to be the link that's here. So you're going to control click on that link to open up a small web page that's going to talk to you about standard deviation. And to calculate the standard deviation, if you scroll down, you should reach this part here, which will walk you step by step of the process of calculating the standard deviation. So you have to calculate the mean, so the average of a certain amount of numbers. And then after you get the average for each number, you're going to subtract the mean and then square the results. And then calculate the mean of those square differences. That's the variance. and then take the square root of that to obtain the population standard deviation. So this is using population to get standard deviation. You don't worry about the whole population thing. We're gonna use something else, but really the sole concept of the SCDEF, that's what we're worried about, right? So we're gonna use this formula to get the standard deviation for, I believe it's the grade of students. Let's see. Write a class called person that has two private the name and age. Oh, it's the age. My bad, not grades. We're gonna get the standard deviation of the ages of people, right? Here you have a small example of what it look like. You'll have three different people, which will be objects with names and their individual ages. You'll add these to a list, and then you're gonna use a class, or sorry, a function that's going to take in a person list. Notice this person list, what type of list is it? What's the data types of the values in this list? Which is you, Thomas.
Sorry, I was muted. Tuples?
No.
Wait.
Take a harder look at this. What are the values inside of this person list? What is P1, P2, and
Oh,
P3?
they are functions and arguments.
No.
No, I have no clue then.
These are objects. These are objects. Check out P1. They're calling a
Oh, you're
person
right.
class and they're passing in two values. I know this is a class, right? Person. First of all, there's not a built-in. There's no search thing of the built-in class in Python called person. So I know this is customized. It's capital P, so I can tell it's a class because their classes start with capital letters. I can kind of infer just by looking at this, this is a class. So they use the class of person to create an object, assigned it to P1. They create an object for P2 and an object for P3. They pass all three of these objects into a list. Yes, you can have a list of objects. So this stdef function, I'm gonna say that again, function should take in a list of objects. So you're gonna have a class of called person that should be able to take in two data members for the person, which would be the name and the age, right? You have everything else that comes with it in a init method to be able to initialize it. And it should have get age. It should have a get age method, right? So really a getter function for the age. Then you're gonna write a separate function, not a part of the person class, right? This is just a regular, you know, basic function. It is not a method. It is a standalone function called stdef, standard deviation. That's going to take as a parameter a list of person objects and return the standard deviation of all their ages. The population standard deviation that uses the denominator of n, not the sample standard deviation, which uses a different denominator. Really, don't worry too much about this line right here. We're going to use what this article is showing us. There's a part of the equation that requires you to take a square root, which you can do by using an exponent of 0.5, which will give you really the result of a square root, right? Python does not have a specific square root function. It involves importing a module, but we haven't learned about modules yet. But pretty much, this is how it should look like at the very end. Do you have any questions?
I don't think so.
All right. Awesome. We're gonna go over the standard deviation here. Let me split the screens. And let's start off. We'll start with the person class because that's the easiest one here. And then afterwards, we can check out the formula here. I always forget the formula every single time I teach this. But let's go ahead and do class person. We'll define our init method, which will take in self. And it needs to take in, I believe, it looks like a name and an age. These should be private. So we'll say double under name is equal to name. And double under age is equal to age. And it seems like we need a get function for the age. So we'll say get age, which simply returns self dot underscore age. Okay. Yeah, it only says here get age method. So that's all we went for. And that's going to take care of our person class here. Let's go ahead and look at the standard deviation. So we'll take it one step at a time. Let me go ahead and copy and paste this here and bring it down with me to help me visualize what I am doing here as I code along. All right. And we do need to calculate the mean of numbers. Let's go ahead. I'm going to use the example right here to copy and paste these here. Where our numbers are going to be whatever is the ages here. So 73, 24, and 48, right? That's what it's supposed to be. We're going to do a define std, what do we call it? Std def. Yeah. Std def, which takes a list of persons or a list of objects, really. List of objects, and the data type will be list. All right. We'll pass for now because I hate the squiggly lines. But I need to calculate the mean, right, of these. So the first step is I need to be able to grab the mean of all the numbers. Well, how do I grab all the ages of each person? Well, I know that I'm going to be given a list of objects, as we see here. We see std-def, and then they're passing the person list, which we've already identified as being a list of objects here. So it should be I should be able to iterate through each one of these objects and take advantage of this get age function, right? Or this get age method to receive that age, right? And as we know, the mean, you want to uh, add up the numbers. Was it add up the numbers? Yeah, add up the numbers and divide by the length of the list, right? Or really the amount of items that you added up. So we should be able to do something like this for person in list of objects. Let's create a variable here. Sum of ages is equal to 0. And we can use that as a tracker where we can say sum of ages is going to plus equal the person dot get age result, right? So for each person I iterate through that list, I'm going to invoke their get age method, which will return to me the age set there and add it to sum of ages. And then finally, we can say mean of ages is equal to sum of ages divided by the length of list of objects. Do I have any questions about the first step, Thomas?
Nope.
Awesome. Right now. So that takes care of calculating the mean, the simple average of the numbers. I believe I did mean correctly. I'm bad at math. Next, for each number, subtract the mean and square the result. So we can say formatted numbers is equal to how do we do this?
On the for loop, I assigned each age to a list.
Yeah, we can definitely take advantage of that. So we can say list of ages is equal to a list. So every time we go through here, we can say list of ages dot append person dot get age. that takes care of that. So afterwards, we can then subtract the mean and square the results. So we'll say formatted ages is equal to um subtract the mean. So it could be something like age minus mean of ages. I can put this in here. Let me see if I can do. I'm really bad at this one, but I'll try. Age minus mean of ages times 0 point. Was it times or
It's
square?
times.
Time? Yeah, I figured. Okay, I'll about double check that. Let's see if I can do some cool stuff here. See if this works. Mm, list of ages. Oh, age. I think this will work. Let's give it a try. Let's give it a try. Let's go ahead and print. We'll print list of ages, and then we'll print out formatted ages. Get rid of pass. And I don't got time, so let me just go ahead and run this. Okay, it's working to a certain extent. Oh, what's going on? I'm getting some weird stuff here, and I think it's because of division. Let me try to floor divide. See that changes this. It did change it, but not. I don't know if it's for the better. Why is it? I don't like it. Huh? What's changing? Let's see if we get something different as we finish this. If not, we'll come back here. I know where this is supposed to be. Um, for age, I think this is working. Let me just screw it. We'll say for age and list of ages, age is equal to age minus, or we can really say age minus equals the mean of ages. Age is equal to age 0.5. So track the mean and then square the results. And then we could say formatted number or formatted ages is equal
Well,
to the list.
is it saying square the result or find the square root of the result?
Let's see. Square the results.
So then we need to actually do times two, or this times two, not 0.5.
You're right. You are right. I hate this formula. That's okay. That's probably why we were getting some weird functionality. Actually, let me do that again. I, I shouldn't have doubted myself. What the heck? Print list of ages. Print format ages. Sir, now we're cooking with chicken. All right. Next, calculate the mean of those square differences. This is the variance. So we can say something like variance is equal to, let's calculate the mean. So we'll say for age in formatted ages. Variance is, we're going to do plus equals, or we say sum of ages is equal to zero. We'll set zero again. Sum of ages plus equals age. And then we could say variance is equal to the sum of ages divided by the length of formatted ages, which will give us the variance. All right. And take the square root of that to obtain the population standard deviance. So we can quite literally say something like return variance multiplied by 0.5. Print answer. And it should be this. And it looks correct from what I remember from previous classes. Do I have any questions, Thomas?
Nope.
Were you on the right track?
Yeah, where I was getting stuck was like right after the first for loop, it was just getting like complex, and I was just like, oh, should I stick this in the first for loop? Should I make another for loop? And I was just going through it, but
Yeah. I mean,
yeah.
no wrong answers. Some will look neater than others, but yeah, pretty much that's how it's going to work. Let's go ahead and stop the recording. That'll be the end of this session.